Okay, this is section 9.5 in Math 113, Business Math 2, or Business Calculus. We covered in class on Thursday the first half of this section on how to recognize and apply the product and the quotient rules when taking derivatives of functions. What we're going to do today is have some problems that will be applications of these skills. It'll involve, one, getting a feel for how they apply, what it is you're able to find when you find the derivative, and two, just some good algebra practice and background, as well as a little bit of calculus in using the quotient and the product rules. I'm assuming when I give you this video that you've got those product and quotient rules that I gave you in class on Thursday written down, and we'll be using them right here. On problem 40, you're given, it's a cost-benefit analysis. You're given a cost function in terms of P, where P is a percent of pollutants that you're going to remove. C of P is equal to 9800 P over 101 minus P. And this, typically on these problems that we've seen involving removing pollutants, it's either they give you the amount, the percent of pollutants you're going to remove, or they give you the percent of pollutants that you're going to allow to remain. And on this one, it's the percent we're going to remove. If you were to ask yourself the question, what would it cost me to not remove anything? The common sense answer would be 0. And sure enough, if you let P equal 0% in this problem, 0 times 9800 would be 0 over 101 would be $0. Now, on this one, you don't really need to know, I have a good feel for these numbers, because if you look at the problem, they ask you what is the rate of change of removing the cost of P% of pollutants. And all that means is to ask what is the rate of change of this function. They mean the instantaneous rate of change. If this is C of P, find the derivative of C prime of P. Now, to find the derivative, the first thing you do is you recognize this is a quotient of two functions. Think of the numerator, this part, as being maybe function g, the denominator as being function h, and use the quotient rule. The way you take the derivative of a quotient, you take the derivative of function g, the function in the numerator. The derivative of 9800p would be 9800. That's g prime. You multiply that by the function h, 101 minus p. That's your h. And you subtract h prime times g, the derivative of the denominator. Now, the derivative of 101 is 0. The derivative of negative p is, think of that as negative 1 times p is the coefficient of negative 1. Your function g is just 9800 times p. All of that over your function h squared, 101 minus p squared. And what the book will want you to do is to simplify that a little bit. This one is not too awful hard to simplify. You might want to get a calculator for part of it. Multiply in the numerator the 9800 times 101. And get 989,800 minus 9800p. Now, be careful with this next term. If you have minus a negative 1, that's just going to be plus 9800p. Over your denominator, 101 minus p quantity squared. The 9800p's cancel, and so what you end up with, a simplified answer for your rate of change, if this is your cost of removing P% pollutants, is 989,800 over 101 minus p squared. That's the answer the book is looking for. Now, if the book asks you to interpret your answer, as we go through the semester, it'll begin to make more and more sense. What this tells me is if I have a current level of pollutants I'm currently removing, say I'm removing 90%, and if I'm curious, how much more would it cost me to remove 1 more percent? To go from 90 to 91. If you evaluate C prime of 90, put a 90 in here for P and see what you get. That would be the cost of removing 1 more percent of the pollutants if production is currently at 90. If production is currently at 40%, what would it cost to remove 41 or 1 more percent of the pollutants. And you just evaluate this at P equals 40, C prime of 40. That's the interpretation of what that gives you. But that's problem 40.